Okay, first of all, we will talk about differentiation. What is differentiation? Differentiation is the action of computing a derivative. The derivative of a function y equals fx of a variable x is a measure of the rate at which the value y of the function changes with respect to the change of the variable x. It is called the derivative of f with respect to x.
Okay, next we go the derivative. What is derivative? If you know in mathematics, the derivative of a function of a real variable measures the sensitivity to change of the function value, output value, with respect to a change in its argument, input value. Derivatives are a fundamental tool of calculus. For example, the derivative of the position of a moving object with respect to time is the object's velocity. This measures how quickly the position of the object changes when time advances. This shows that the process of finding derivative is called differentiation. Have you been thinking that what is the purpose of differentiation in our daily basis and why we use differentiation? Okay, firstly, differentiation can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions such as cost, strength, amount of material used in a building, profit, loss, and many more. Derivatives are met in many engineering and science problems, especially when modeling the behavior of moving objects. Besides that, differentiation allows us to find rate of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. As you know, I have taught you earlier that some problems in calculus require finding the rate of change or two or more variables that are related to a common variable, namely time. To solve these types of problems, the appropriate rate of change is determined by implicit differentiation with respect to time. Note that a given rate of change is positive if the dependent variable increases with respect to time and negative if the dependent variable decreases with respect to time. The sign of the rate of change of the solution variable with respect to time will also indicate whether the variable is increasing or decreasing with respect to time. Now, we are going to the example question on how we are solving the related rates problem. Let's go.
So today we're going to solve a problem from Application of Differentiation. So let's look at for the example. So a water tank has the shape of inverted circular cone with base radius 2 meter and height 4 meter. If the water is being pumped into the tank at a rate 2 meter cube per minute, find the rate at which the water level is rising when the water is 3 meter deep. So the key point here is water is being pumped into the tank at a rate 2 meter cube per minute, which is it refers to dV over dt, which is equal to 2 meter cube per minute. So the question is find the rate at which the water level is rising when the water is 3 meter deep. So it is referred to dH over dt. dH over dt. So we need to find dH over dt when h is equal to 3. So the first step I'm going to do is I need to separate dH over dt, which is what we want to find, into two related rates. So dH over dt dH So what I'm going to substitute the blank here is based on our information given. So we are given dV over dt. So we are going to substitute dV here. dV. So in order to find volume of cone is 1 over 3 pi r squared h. So we have r here. We don't want r. So we're going to substitute r to a value. So in order to find r, we do like this. R over h is equal to 2 over 4. So R over h is equal to 1 over 2. We bring h to the right hand side, so R is equal to 1 over 2h, or h over 2. So we already have the value of R, so we are going to substitute into V. So V is equal to 1 over 3 pi h over 2 squared h. So we just need to simplify this. 1 over 3 pi over 4 h cubed. So multiply with 1 over 3 will become pi over 12 h cubed. So we need to, second step is we need to differentiate v. So it will become dv over dh. So dv over dh is equal to I over 4h squared. So now we can find dH over dt. So dH over dt is equal to dH over dV multiply with dV over dt. So if you realize, we already have the value of dV over dt, which is equal to 2. So we just need only to focus on dH over dV. But if you realize, we don't have dH over dV, but we have we don't have value of dH over dV, but we have dV over dH. So what we need to do is we just invert the fraction, so it will become like this. Four over pi h squared multiply with 2. So when h is equal to 3, so we're going to substitute 3 into the dh over dt. So 4 over pi 3 squared over 2. So it will become 8 over 9 pi. So if we use calculator, we will get 0.28 meter per minute. This is our answer.
What I can conclude here is that we all have been using the application of differentiation in our daily life in order to solve any math-related problem. As you can see, if two related quantities are changing over time, the rates at which the quantities change are related. We can clearly say here that differentiation is very important to help us solve many types of real-world problems.